So welcome to GATE class. Today we will solve some problems related to Laplace transform. So the problem is find the find the inverse Laplace transform. Find the inverse Laplace transform of the following excess. So the first part is the Laplace transform xs is equals to 1 divided by s plus 1, and the real part of s is greater than minus 1. The second part is xs is equals to 1 divided by s plus 1 and real part of s is less than minus 1. The third part is xs is equals to s divided by s square plus 4 and the real part of s is greater than 0, and the last part is xs is equals to s plus 1 divided by s plus 1 whole square plus 4 and the real part of s is greater than minus 1. So this is our Laplace transform. Now we need to find out the corresponding time domain signal. We need to find out the corresponding time domain signal from this Laplace transform. So let us do the first. So first problem is part A is 1 divided by s plus 1 and the ROC is real part of s greater than minus 1. So in order to do this problem, first we will see that the ROC is given that real part of s is greater than minus 1. It means it is talking about the causal signal. So it is basically the time domain signal. The time domain signal is nothing but it is a right-sided signal. So what we need to do, we have to remember some standard Laplace transform pairs. Like we have the signal that is e raised to the power minus at into ut, and if we remember, so in our previous lecture, what we find out that the Laplace transform is 1 divided by s plus a, and the ROC is the real part of s is greater than minus a. The real part of s is greater than minus a. So now if we put a is equals to 1, so what we will get? We will get e raised to the power minus t into ut, and the Laplace transform of this is 1 divided by s plus 1, and the ROC is real part of s is greater than minus 1. So the inverse Laplace transform of this signal is e raised to the power minus t into ut. So the inverse Laplace transform of this is e raised to the power minus at into ut. So one of the important point I want to tell you that the ROC, I want to tell you about the ROC. So ROC is, this is minus 1, this is sigma, this is j omega. Now the ROC is real part of s greater than minus 1. So this is our ROC. So this is the ROC. So basically we want, if we see the stability of the system, if we see the stability, then we can say that since since the ROC since the ROC since the ROC includes the j omega axis, so we can say that we can say that we can say that the system the system is the system is stable. So we can say that the system is stable because the ROC includes the j omega axis. The ROC includes the j omega axis. So let us do the second part. So it is xs is equals to 1 divided by s plus 1, and the ROC is provided, that is real part of s is less than minus 1. Now we can see that the standard form is minus e raised to the power minus at into u minus t. In previous lecture we have solved this, we find out the Laplace transform for this, and the Laplace transform for this signal is 1 divided by s plus a, and the ROC is nothing but real part of s is less than minus a. Now if we put a is equals to 1, then it will become minus e raised to the power minus e t u minus t, and the Laplace transform should be 1 divided by s plus 1, and the ROC is nothing but the real part of s is less than minus 1. So basically if we have xs, that is 1 divided by s plus 1, and the ROC is given, that is real part of s is less than minus 1, then the time domain signal is minus e raised to the power minus t u of minus t. So this is the time domain signal. This is the time domain signal. Let us do another problem. That is part C. So part C is xs. So xs is given. The xs is given as s divided by s square plus 4, and it is real part of s is greater than 0. So if we analyze this problem, then we can easily find out that the standard form is cos omega naught t into ut. So the Laplace transform for this signal is s divided by s square plus omega naught square, and the real part of s is greater than 0. Now if we compare these two expressions, then we can find out that omega naught is 2. So the inverse Laplace of s divided by s square plus 4 is equals to cos 2t into ut. So the inverse Laplace transform is, and also it is basically it is causal, it is right sided, because we have taken the ut, so it is basically the right sided. It is the right sided signal. One important point I forget to tell you in the previous example. Let me explain this important point. So in previous example I forget to tell you the ROC concept. So in that case the ROC is the real part of s less than minus 1. So it is minus 1 here, it is, then less than minus 1, if this is ROC, if this is sigma, this is j omega, then this is the ROC. So what is the important point? That the system the system is not stable since ROC does not contain the j omega axis. In the system does not contain the ROC does not contain the j omega axis. So let us do another problem, that is part D. So part D is, we need to find out the inverse Laplace transform that is given s plus 1 and divide by s plus 1 whole square plus 4, and the ROC is given, that is real part of s greater than minus 1. So ROC is given here. Now we need to solve this problem. So the problem is the excess is given, that is s plus 1 divided by s plus 1 whole square, and it can be written as 2 square, and the ROC is given, that is real part of s greater than minus 1. Now we can see that cos omega naught t ut, the Laplace transform is s divided by s square plus omega naught square, and the ROC is real part of s greater than 0. Real part of s greater than 0. Now we can apply the property. So what is the property? The property is, if we have xt, the signal, and Laplace transform is xs, then if we multiply it with e raised to the power minus s naught t with xt, then the Laplace transform will be s plus s naught. So here we can use this property. So what we will find out, that cos omega naught t into ut, this is the Laplace transform. Then if we multiply it with e raised to the power minus t, that is s naught is equals to 1. S naught is equals to 1 because we need s plus 1. So e raised to the power minus, if we multiply it with e raised to the power minus t, then what we will get? So we will get, so e raised to the power minus t cos 2t into ut. So here omega naught is equals to 2 and s naught is equals to 1. So t e raised to the power minus t cos 2t into ut, the Laplace transform should be equals to s plus 1. So wherever you have s, you have to replace with s plus 1. So s plus 1 divided by s plus 1 whole square plus 2 square, and the real part of this is this will change. It will be equals to greater than minus 1. So e raised to the power minus 2 minus t cos 2t ut. The Laplace transform of this is nothing but s plus 1 divided by s plus 1 whole square plus 2 square, and the ROC is real part of s greater than minus 1. So the inverse Laplace transform of this signal is e raised to the power minus t. So the Laplace inverse of xs is e raised to the power minus t cos 2t into ut. So let us do another problem. So find the inverse Laplace transform. Find the inverse Laplace transform Find the inverse Laplace transform of the following axis of the following axis. So axis following axis are given. So axis is equals to 2s plus 4 divided by s square plus 4s plus 3, and the real part of s is greater than -1, then b is xs is equals to 2s plus 4 divided s square plus 4s plus 3, and real part of s is less than -3, and the part c is xs is equals to 2s plus 4 divided s square plus 4s plus 3, and it is -3 is less than real part of s less than -1. So let us solve this problem. So the solution is the part A, it is xs, it is equals to 2s plus 4 divided by s square plus 4s plus 3, and the ROC is real part of s is greater than -1. So xs is written as, we can take 2 common, then it is 2s plus 2 divided by s square plus 4s plus 3, and it is equals to c1 divided by s plus 1. Basically we can factorize this. So before that there is one more step, so it is 2s plus 2. So we can find out this we can find out the inverse Laplace transform by using the partial fraction procedure, by using the partial fraction method. So I am going to tell you the partial fraction method, and by using this partial fraction method we are able to find out the inverse Laplace transform. So first we have to see the degree. If the numerator degree, so the condition is if the numerator degree is less than the denominator degree, then we can do the partial fraction, then we can do this analysis. And if the numerator degree is higher or equal to the denominator, then we have to divide. After that the resulting expression, we can do the partial fraction analysis, and all these examples we will see later, all these examples. Right now here the highest degree for that numerator is 2 and is 1, and the highest degree for denominator is 2, so it is square s square here, so there is no problem, we can directly write in terms of partial fraction. So here it is s square plus 4s plus 3, so it can be written as s square plus 3s plus s plus 3, so it is equals to twice of s plus 2 divided by s plus 3 plus 1 s plus 3. Now it is twice s plus 2 divided by s plus 1 s plus 3. So basically we have written it in the form of factors, so we can write it in partial fraction form as xs is equals to 2 s plus 2 divided by s plus 1 S plus 3, and that is equals to C1 divided by S plus 1. We don't know the value of C1, we need to find out the value, plus C2 divided by S plus 3. So this is called partial fraction method. Now what is C1? How to get the C1? So to get the C1, we have to just see the denominator of this C1. So that is it is S plus 1. Then we have to multiply it with XS. So XS, multiplication of XS, and we will put S equals to minus 1. Basically the pole. So what is pole here? The pole is S equals to minus 1, and here the pole is S equals to minus 3. So what we will get here? We will get S plus 1 multiplied by XS, that is 2, S plus 2 divided by S plus 1, S plus 3. So it will cancel out, and we have to put S is equals to minus 1. So the result we will get is it is equals to twice, then minus 1 plus 2, and then minus 1 plus 3. So it is equals to twice 1 divided by 2. So it is 1. So C1 is 1. So we are getting C1 is equals to 1. Likewise here we can find out the value of C2 by adopting the same procedure. So it is S plus 3 multiplied by XS, that is twice S plus 2 divided by S plus 3, S plus 1 at S is equals to minus 3. So here we can cancel out this. So what we will get, it is twice, put in x equals to minus 3. So it is minus 3 plus 2, then it is minus 3 plus 1. So what we will get here is 2 into minus 1 divided by minus 1. So it is minus 2. So it is minus 1 will cancel out, and 2 will cancel out. So C2 is also equals to 1. So we can write X as is equals to 1 divided by S plus 1 plus 1 divided by S plus 3. 1 divided by S plus 1 plus 1 divided by S plus 3. So now we need to solve these various parts that we have given. So part A is, the excess is given as 2S plus 4, and it is S square plus 4S plus 3, and the ROC is real part of S greater than minus 1. Now we have this excess that we have find out through that partial fraction analysis. So it is equals to 1 divided by S plus 1 plus 1 divided by S plus 3. Now please see the ROC. Please concentrate on the ROC. Now after concentrating on the ROC, we can find out the ROC of a real part of S is greater than minus 1. It means that it is talking about the right sided signals. So since ROC, the region of convergence indicates that xt is nothing but xt, that is inverse Laplace transform of xs, is a right-sided signal. It is right-sided signal. And also we can see that how many poles are there. So poles are present at s equals to minus 1 and s equals to minus 3, and the ROC is real part of s greater than minus 1. So which pole is bigger? So the s is equals to minus 1 is bigger, is maximum pole. That s is equals to minus 1 is maximum that s is equal to minus 3. It means the ROC ROC is basically the real part of s is greater than minus 1. So it is outer to the right to the rightmost pole. It is right sided signal. ROC is right. ROC is right to the rightmost pole. Because if we see the pole 0 plot, if we see the plot 0 pole 0 plot, then this is -1 and this is -3. So this is -3 and this is -1. And what is the ROC? ROC is real part of S greater than -1. So this is ROC. This is region of convergence. So basically the ROC is, it is right to the rightmost pole. So it is right to the rightmost pole. It is right to the rightmost pole. So it can be easily seen that this xt is right sided signal. So xt is nothing but e raised to the power minus t into ut plus e raised to the power minus 3t into ut. Please check this. Please check this relation. So this is our xt. This is our xt. Let us solve another problem. Let us solve the part B, and that xs is given. Xs is equals to 2s plus 4 divided by s square plus 4s plus 3, and ROC is real part of s less than -3. So again we can separate this xs into partial by using partial fraction. That already we find out that it is 1 divided by s plus 1 plus 1 divided by s plus 3. So if we analyze the ROC, so this is -1 and this is -3. This is sigma, this is j omega. So we can see that the ROC is less than -3 means it is less than -3 means in this side. So ROC is less than -3 means it is in this side. This is the ROC. Now we can see that the ROC indicates that basically ROC indicates that it is left-sided signal. It is left-sided signal. So we can easily say that the xt is left-sided. Xt is left-sided signal. So we can easily say that the ROC is left to the leftmost pole, that is s is equals to -3. So ROC is left to the leftmost pole, that is s is equals to -3. So what is xt? So xt is written as minus e raised to the power minus t into u minus t minus e raised to the power minus 3t u minus t. So this is our solution. This is our solution. Let us do the part C. So part C is given. The part C, the Laplace transform is given for part C, that is equals to xs is equals to, xs is equals to 2s plus 4 divided by s square plus 4s plus 3, and the ROC is provided, that is -3 is less than real part of S is less than -1. So the ROC is basically we have this is -1 and this is -3. So the ROC is in between the -1 and -3. So this ROC is in between the -1 and -3. So this is sigma, this is j omega, and this is -2. So the ROC is between -3 and -1. The ROC is between -3 and -1. So again we need to find out that inverse Laplace transform by just utilizing this expression, that 1 divided by s plus 1 plus 1 divided by s plus 3. Now if we break this ROC into two parts, then we can analyze better. So it is real part of s is less than -1, and also the real part of s is greater than -3. This indicates that the real part of s is less than -1 and the real part of s is greater than -3. It means that if we consider this signal, that is real part of s is less than -1, it means that this signal is left sided. This signal this indicates left sided signal. This indicates the left sided signal. This indicates the left sided signal. And this is basically that ROC is a real part of s greater than c. So it is right sided. It is right sided signal. It is right sided signal. So we can find out, we can write xt is equals to, since it is left sided, so e raised to the power minus e raised to the power minus t u minus t, and it is right sided, so we can write it e raised to the power minus 3t into ut. So we have -1 and -3. So in between these two vertical lines we have region of convergence. We have region of convergence. So next problem is, let us do next problem. It is also related to the inverse Laplace transform. So the next problem is so find out the inverse Laplace transform of xs, that is equals to 5s plus 13 divided by s square plus 4s plus 13, and the real part of s is greater than 0. So the answer is, the xs is given, that is equals to 5s plus 13 divided by s square plus 4s plus 13, and it can be, it is written in this form: c1 divided by s plus c2 divided by s plus 2 minus j3, and c3 divided by s plus 2 plus j3. Actually there is intermediate step that I did not tell you. So it is xs is equals to 5s plus 13 divided by s. So it is s minus of minus 2 plus j3 and s minus of minus 2 minus j3. So it is s2 minus j3, and it will give s2 plus 2 plus j3. So we have written in this form, that is partial fraction expansion form. So what we will get c1. So c1 is basically s multiplied by xs at s is equals to 0. And what is the value we are getting? So the value we are getting is s multiplied by 5s plus 13 divided by s square plus 4s plus 13 and s is equals to 0. So it is equals to basically this s will cancel out, so it is equals to 5 into 0 plus 13 divided by 0 plus 4 into 0 plus 13. So it is equals to 13 divided by 13, that is 1. So c1 is equals to 1. So c1 is equals to 1. Now we can find out c2. So c2 is s plus 2 minus j3 multiplied by xs, and at s is equals to minus 2 plus j3, and solution is minus 1 divided by 2, 1 plus j. Please check. Likewise, c3 is calculated as s plus 2 plus j3 multiplied by xs at s is equals to minus 2 minus j3, and the solution is minus 1 by 2, 1 minus j. The solution is minus 1 by 2, 1 minus j. So c1 and c2 and c3 we find out. Then xs is written as 1 divided by s minus 1 divided by 2, 1 plus j, 1 divided by s plus 2 minus j3 minus 1 divided by 2, 1 minus j, 1 divided by s plus 2 plus j3. Now we can see that the ROC, is basically the real part of s, that is greater than 0. Thus xt is since the ROC is given as, since the ROC is nothing but real part of s greater than 0, so it indicates that it is a right-sided signal. It is right-sided signal. The xt is right-sided signal. So xt can be written as 1 divided by s. The inverse Laplace transform is nothing but ut. Please check. And it is 1 divided by 2, 1 plus j, and it is nothing but e raised to the power minus 2 plus j3 into t ut. This expression, please check. Then minus 1 divided by 2, 1 minus j e raised to the power minus 2 minus j3 into t into ut. Please check this expression also. It is very simple. Now finally what we can write xt in most simplified form is 1 minus e raised to the power minus 2t cos 3t minus sin 3t into ut. So this is our solution, and there is alternative solution also. There is alternative solution also possible. So we can write xs as 5s plus 13 divided by s square plus 4s plus 13. So it can be written as xs is equals to 5s plus 13 divided by s square plus 4s plus 13 is equals to c1 divided by s plus c2s plus c3 divided by s square plus 4s plus 13. So what is c1? So it can be written in this form also. So what is c1? So c1 is s into xs for s is equals to 0. Please check the solution is 1. Then we have c2s plus c3 divided by s square plus 4s plus 13. It is equals to 5s plus 13 divided by s square plus 4s plus 13 minus 1 by s. It can be written in this manner also. So it is minus s plus 1 divided by s square plus 4s plus 13. So how this expression is coming? Please check this relation in the previous slide. Please check this relation. We have 5s plus 13 divided by s square plus 4s plus 3 is nothing but c1 divided by s plus c2s plus c3 divided by s square plus 4s plus 13. So basically this term is equal to this term minus c1 divided by s. And what is c1 divided by s? It is 1 divided by s only. So this relation can be written as c2s plus c3 divided by s square plus 4s plus 13 is equals to 5s plus 13 divided by s square plus 4s plus 13 minus c1 divided by s. And what is c1? c1 is 1. So we can see that's why we have written this relation. Here c1 is equals to s. So it is equals to c2s plus c3 divided by s square plus 4s plus 13 is equals to minus 1 s plus 1 divided by s square plus s square plus 4s plus 13. Then c2, if we compare the coefficients, then c2 we will get c2. So what is the value of c2 we will get? So c2 is equals to please check, c2 is minus 1 and c3 is 1. So c2 we will get is minus 1 and c3 is 1. So finally we will get find out, say, just to compare the coefficient. So c2 is equals to minus 1 and c3 is equals to 1. So finally we will get xs. So what is xs? So xs is nothing but 1 divided by s. Please check this. Relation. So xs is nothing but c1 divided by s plus this term. So c1 we are getting is 1, c2 we are getting is minus 1, and c3 we are getting is 3. c3 we are getting is 3. C3, please check that C3 we are getting is yes, C3 we are getting is 3. Basically C3 we are getting is 3. So 3. So what is xt? So what is xt? So xt is we can written xt is, we can write xt is equals to ut minus e raised to the power minus 2t cos 3t into ut plus e raised to the power minus 2t sin 3t into ut. So this is our relation, and that is similar to the previous part. If we take ut common, then that is similar to the previous part. If we just compare, if we just see that what is the previous part, whatever we are getting, it is same, it is similar. So finally after combining ut terms, so we will get xt is equals to 1 minus e raised to the power minus t cos 3t minus sin 3t into ut. So finally we are getting the same expression as we solved in the previous example. We see in the previous method, the same we are getting, and also from the alternative method we are getting the same thing. So let us do another problem on inverse Laplace transform. So the question is find the inverse Laplace transform of xs, that is equals to s square plus 2s plus 5 divided by s plus 3 s plus 5 square, and the ROC is real part of s greater than minus 3. So the solution of this problem is, we can see that xs has simple pole at s is equals to minus 3, and it has multiple pole at s is equals to minus 5. So the poles are s is equals to minus 3, minus 5, and again minus 5. So we have double pole here. So how to solve this type of problem? So in order to solve this type of problem, we can write xs in this form: c1 divided by s plus 3 plus lambda 1 divided by s plus 5 plus lambda 2 divided by s plus 5 square. So this is equation number 1. So how to find out c1? So c1 is nothing but s plus 3 multiplied by xs at s is equals to minus 3. So it is equals to s plus 3 multiplied by c1 divided by s plus 3 at s is equals to minus 3. So the solution is xs is basically it is equals to s square plus 2s plus 5 divided by s plus 3 s plus 5 square. So it will be cancelled out. So when we put s equals to minus 3, then it is 9 minus 6 plus 5 divided by minus 3 plus 5 is 2 square, so it is equals to 3 plus 5 8, so 8 divided by 4, that is equals to 2. So C1 is equals to 2. C1 is equals to 2. Now find out C2, lambda 2. First find out lambda 2. So lambda 2 is equals to s plus 5 square. This is the procedure. First we find out the lambda 2, that is double poles coefficient. So it is s plus 5 whole square multiplied by s xs at s is equals to minus 5. So it is s plus 5 square, and what is xs? It is s square plus 2s plus 5 divided by s plus 3 s plus 5 whole square, and it is cancel out. So it is s is equal to minus 5 is minus 5 square plus 2 into minus 5 plus 5 divided by minus 5 plus 3. So it is equals to 25 minus 10 plus 5 divided by minus 2. So it is equals to 15 plus 5 divided by minus 2. So it is minus 10. So lambda 2 is minus 10. Lambda 2 is equals to minus 10. Now what is lambda 1? So lambda 1 is equals to d by ds of s plus 5 square into xs at s is equals to minus 5. This is the method to find out the value of lambda 1. So what is the value of lambda 1? So lambda 1 we will get is minus 1. Please check this. So lambda 1 we will get is minus 1. Please check this relation. So xs is equals to 2 divided by s plus 3 minus 1 divided by s plus 5 minus 10 divided by s plus 5 square. So since the ROC is given, as real part of s greater than minus 3, it means that it is right to the rightmost pole. It is, so basically xt is nothing but xt is, since the ROC, so the poles are s is equals to minus 3, minus 5, minus 5, and the ROC is real part of s greater than minus 3. It means the signal is right sided. The signal is right sided, and the ROC is right to the rightmost pole. The signal is right to the right, the signal xs is right to the rightmost pole. So we can easily say that xt is right sided signal. So the solution is xt is equals to 2 e raised to the power minus 3t minus e raised to the power minus 5t minus 10t e raised to the power minus 5t multiplied by ut. So this is a solution. So note that the simpler way of finding alpha, so there is an alternate method. there is alternate method. So let us discuss the alternative method. Let us discuss the alternative method. So please note that there is a simple method to finding out the value of lambda 1 without using the differentiation. So what is the step? So step 1, find out the C1, find out C1 and lambda 2 according to the regular procedure, according to the regular procedure. And step 2, substitute, substituting the value of C1 and lambda 2 and C1 value of lambda 2 and C1 in equation 1. What we will get? We get s square plus 2s plus 5 divided by s plus 3. So what is equation 1? Please check this. What is equation 1? So the equation 1 is this equation. Basically we have to go to this slide. Okay, yes, this is equation 1. So what we are doing, we have find out that C1 and lambda 2, and we have used this C1 and lambda 2 in this equation number 1. So what we will get here? So we will get here 2 divided by es plus 3 plus lambda 1 divided by s plus 5 minus 10 divided by s plus 5 square. So what we will do, we can set s is equals to 0. So setting s is equals to 0 on both sides, setting s is equals to 0 on both sides of the expression derived, we get 5 divided by 75 is equals to 2 divided by 3 plus lambda 1 divided by 5 minus 10 divided by 25. So lambda 1 is equals to minus 1. So this is very simpler method. Basically we don't need to do any differentiation because it is very difficult to find out the differentiation. So lambda 1 is equals to minus 5. Then after finding this value, the procedure is same. The rest of the procedure is same. So let us do another problem. Find out inverse Laplace transform of xs, that is equals to 2s plus 1 divided by s plus 2, and the ROC is real part of s is greater than minus 2. So it is basically check the check the numerator and denominator degree. So step 1, so this type of problem, step 1, check the numerator and denominator degree. So we can see that both numerator and denominator, the degree is basically the highest degree is 1. The degree is 1. So we can write this expression in this form. So what we will do, we will divide. We will do division. When we have same degree, then we can perform the division first step. So what is that division result? So it is 2s plus 2. So this is minus 1. So this excess is written as 2 minus, it is written as 2 minus it is written as there is 2s plus 4. There is mistake here. It is 2s plus 4. So it is minus 3. So 2 minus 3 divided by s plus 2. So whenever we have same degree, we have to perform the division. First you have to perform the division. So now basically we want to avoid any pole at the origin. What is our aim? We want to avoid any pole at the origin. So this is our xs. So what we can write, xs is equals to 2 minus 3 divided by s plus 2, and it is real part of s greater than minus 2. It means it is right sided signal. So it is right sided signal. It is right sided signal. So xt is nothing but 2. What is Laplace inverse Laplace transform of 1? We need to find. Then 3 inverse Laplace transform of 1 divided by s plus 2. So what is inverse Laplace transform of 1? So this is del t. So because del t has Laplace transform 1, then inverse Laplace transform of 1 is del t, and it is 3 e raised to the power minus 2t into ut. Please check this relation. Please check this relation. So the solution is 2 del t minus 3 e raised to the power minus 2t into ut. So this is our relation. This is our xt. Now we can see that since we have pole at minus 2 and the ROC is like this. So basically, if we discuss the stability, then the system is that ROC is containing the j omega axis. The ROC is containing the j omega axis. So basically it is stable. So basically it is a stable system.